Ah,
There we go.
there it is. Third party would be YouTube, and the rest of us are on the screen, everybody. We are members of the board and hardcore supporters, members, if you will, of the Central South Coast Longtime Astronomy and Telescope Club, the Santa Barbara Astronomical Unit. And this is the SBAU Astro Hour, one weekly online live vlog, live on Monday mornings anyway, using Zoom. Going to focus on the latest space news and discoveries, cutting-edge cosmology and hardcore astrophysics, featuring some of the brightest and most knowledgeable men I know in town. Don't include myself in that, but I do ask some questions. I'm your host, Vice President of the club, Ron Herron. We'll meet the Brain Trust, the rest of the club's movers and shakers in just a moment. I think we're back on YouTube. You can watch us and comment on a question using YouTube most weeks, and we saved all 3 years plus. We're into our 4th year of broadcasting, if this is what this is called, telecasting, I guess. The show is Mondays, 11 to noon. Plan on joining us. At least come to our club meetings, usually on the first Friday. Next month, June, it'll be the second Friday, which would be the 14th of June, for our Astro Programs Manager up at the Museum of Natural History, John Winkowski, doing a bang-up 1-hour talk about moons of the solar system. Interestingly enough, we've switched the second Saturday to the first Saturday, and guess what? That's on the 1st. If you look at your June, your month of June, and welcome aboard, SBAU.org. Let's talk about what we're going to talk about, and then I'll introduce you to the guys. New comet in the sky. Actually, it's an old friend making a return visit. Good old 13P Old Bears is back. We got a new moon in town this week, bringing zodiacal light again. There's a new spring asterism out there called the Great Diamond. Can't wait to hear about it. Also, the Arch of Spring is up in the western sky. Leo exiting stage left. It's got the sickle in it. And get this, going to talk about the galaxy we used to see in the outer limits, closing credits. Looks like a Mexican hat. And as far as stars, when they grow and evolve, well, size matters, everybody. Let's meet the man in charge right now, beloved President Jerry Wilson. Hello, Jer.
Hello, good
Cat
morning.
Borgie, he's at control, and I guess we've solved our problem thanks to Tom Totten, our webmaster, I guess, and a new, password or a new way to get us on board. I don't see the little red sign. Are we on YouTube right now?
We are
Yes.
on YouTube, yes.
Okay. And he and his wife enjoyed the show Friday night. We'll talk a little about that if we can. Chuck McPartland is on, I guess, duty with his wife on their anniversary, something Tim Crawford just went through. Well, I'll introduce you to Tim, resident lens and telescope expert.
Howdy.
Hi there. Where did you take Karen? Did you take her to an expensive restaurant, you animal? That was what, a week ago?
Yeah, I walked all the way to the kitchen.
Okay. Okay. You just can't join us on screen. Tom Whittemore, editor of the
Morning.
SBAU monthly newsletters on the screen. He's also
Morning.
a bird watcher and a former science instructor out at Westmont College. Our connection to their incredible observatory out there. His wife is Maureen. And Bruce Murdoch, longtime supporter, telescope enthusiast, and an incredible man to know. Spreads his time between us and the Santa Barbara Theater Organ Society, for which he's the president. I think he gives us a little more time. That's that beautiful, incredible stage organ downtown at the Arlington Theater. So we start the show for Astro Hour number 167 into our 4th year for May the 6th through the 12th, 2024, with President Jerry's silly side. His sense of humor is unbounded. And for years, I could have saved all of these in a special file, but it would have bulged out by now. Here we go. These are the 6. What is this? Fred and Ginger? That's how you use it. 6 boxes, all detailing footprints left on the moon, with some becoming new dance steps for an alien Arthur Murray course and dancing. Yeah, put your little foot here and put your other foot there. Okay, that was good. I like it. And I took an Arthur Murray course once. It was the end of civilization as we knew it. All right, let's go to another one, Jer. because I never know which one's coming up, but I get them all. We all do.
Okay, there.
Good laugh. No,
Got that?
you trying to click on something and it's not working for you?
No. You see, did the cartoon change?
Nope.
No,
No.
Uh-oh.
you have the same
Okay.
problem I did.
Got a new problem. I got about 8 or 9 listed here. There's
There.
Problems?
Yep.
here we are, the stick figures with bubble heads, all
Yes.
arguing about Pluto. In fact, they're I guess they're fighting over there, having a fight, and one guy intercedes and goes, "Hey, guys, stop it. Stop fighting. A spaceship is taking pictures of Pluto at this very moment." And there it is, pictured in the distance. Pluto, a completely new world, 3 billion miles away. We're visiting it. And it looks like they're working things out. Yeah, I know. One of the litigants said we were fighting over whether it's a planet or not, and they all
The
three
fight
get into
starts
it.
again.
Yeah, there are people that are going to be like flat earthers on Pluto. They always want to keep it in.
Neil deGrasse Tyson's famous phrase on this topic is get over it.
Get over it. Okay, here's the old couple. Oh, I like this one. It's a new form of reminiscing called nostalgebra. Old couple sitting in the living room, and he asked her, "You remember coefficients, honey?" "No, I don't." She said, "Well, me neither. Coefficients. I'm trying to remember coefficients. Is that trigonometry?"
No, algebra.
Algebra.
Oh, okay. And here's a reminder in case you forgot. April is procrastination aware. Oh, wait a minute. Awareness month. That was last month, wasn't it? What we're in May.
Yeah,
Well, I
Tax
put it
month.
off. I like that one. Keep that one, guys. Now we're sailing through them.
Well, that's it. We only had 4 this week. Some weeks we get a flood of them and some weeks we don't.
Well, then we get to talk about Matthias or something, MATT 111. What is it? A star cluster?
We'll get to it. Yeah.
That'll come up. Interesting stuff, gentlemen. All right, regale me. Educate the host. Mr. President, where are we going first into the night sky as we get into May? Friday night was
Going
interesting. You were
to,
also-
let's see what happened to my Zoom here.
Glad this isn't a spaceship with you as our Captain Kirk.
Yeah, right.
James
Oh no, I wouldn't
Tiberius.
be the pilot.
We'd all be beamed somewhere. But I'm amazed that you can do it. I certainly wouldn't be able to. Tom Totten needs to come back on board. Here we
Okay,
go.
this is a new comet in the sky right now. It's Comet Olbers, discovered by Heinrich Olbers. You can see this table, right?
Mm-hmm.
Okay. And it was discovered in 1815.
Mm-hmm.
It's not terribly close to Earth. It comes, let's see, what is it? Semi-major eccentricity. It's almost a circular orbit. It has a period of orbital period about 70 years, but it changes, as you know, note from the paragraphs on the talking points, which are not displayed here. It has a period that is fluctuating slightly over the years, and that makes it hard to recover. It's about 80 years, as we said, or 70 years. And but the comets, you remember, are always burning. They have little rocket motors all over them, and when the sun hits them, it spits out all this jet of volatile materials, and that is constantly changing the orbits of these comets. So it's not just that measurements got better, it's that the comet keeps moving its orbit around.
Huh.
Well, I certainly am not going to correct the president, but the term new comet probably is an oxymoron. There is no such thing as a new comet.
That's true, unless we launch it. We had what Sean Kelly made a comet for us as a lab demonstration at one of our meetings by mixing water ice and dry ice and liquid nitrogen together, freezing it all together with some dirt and stones.
Are they defined as originating in the Kuiper or the Oort, or can they come from?
There's no one place. They come from everywhere. They come
that
from the
right?
Kuiper Belt, the Oort cloud. Some of them possibly even come from interstellar space. You know, those three stony ones that we got years ago, they all came from interstellar space, and they could just as well have had some leftover volatile materials on them. Then that would have acted and made them look like a comet. So there's no one place. Most of ours comes from the Oort and the Kuiper cloud, however, the Kuiper belt. Now, this little plot we have here shows the path of the comet over 2023 and 2024. Here is January 16, 2024, and it's working up this way. Here we are at April 15, and then here is right about where we are. There's May 5th. So it's right about there, just past that. And you see it's crossing the Milky Way. This is May 15, May 25. So by June, it'll have crossed this path of the Milky Way. And that makes it a very interesting photographic object because there's a lot of background structure, a lot of things in the background to see.
Oh, yeah.
And this covers that period from May 1 up until June as it passes over the Milky Way. And you get all of these objects in here.
There's Tom's clusters, 30, 36, 37, 38.
Right,
Yeah.
right. And
He
Auriga.
loves those. Yep.
Yeah.
Well, do you mind going back to the last photograph, the picture diagram real fast? What does that curve at the bottom represent again? I missed that.
This one?
Yeah, what's it doing? Is that the path of the
Yeah,
comet?
that's the path the comet in the sky. It has like
From Earth.
retrograde motion because
Oh,
of
it's
the
a
Earth's orbit.
retrograde. Oh,
Yeah.
Okay,
This
got
is the
it.
path of the comet as the sky as seen from Earth.
Okay.
Okay. But I get the impression we only have one or two comets at a time. Is the solar system
No.
just filled with them? Or?
You can look up on the internet, go to Google and put in comets. And you can see all the comets that are known in the sky. Most of them are very hard to find. They're very faint. Comet Halley is even there. It's just past its farthest point from the sun. And it's started to head back toward the sun again and toward the inner solar system. But right now, I think it's magnitude 20 or something. It's very, very faint.
Yeah.
But they track every one of these things, and there are thousands of them.
And you're talking, you said that Olbers here is a Halley type
Yes.
comet.
Yeah.
Halley type? What does a type mean?
It means it has a period of about the same place, about the same time. What is it? Halley's is 76
Halley's is
years.
76 years.
Yeah.
And this is what, 60,
60.
65? Yeah, so it's
69 years. It's almost 70 years.
yeah.
Have any of you been able to see this?
Pardon?
Have any of you been able to see this comet in the sky?
Not yet.
Not me, because of the clouds we've always been having, but it is
Yeah,
visible
ditto,
in all
and
telescopes now. It's about magnitude 8, I think, right now.
Oh, nice. It's up in Auriga too. Ooh.
Does science know the origin of all of them? Does the 60 or 70 years make it Kuiper belt or the
Well,
asteroid belt?
In a sense, yes, because if you can spot a moving object in the skies, like an asteroid or a comet, if you get 3 observations of it, 3 independent observations where it's in different places in the sky, you can then use that information to calculate its orbit. And so you can draw a big ellipse on a chart and see where it's been. You can see where it came from. If the ellipse goes out to the Kuiper belt, then it came from the Kuiper belt.
But it takes
Jerry, maybe we can do this in another meeting, but I was really curious when this came up. They were talking about comets. You've even talked about this in the past. Some of these comets won't return.
That's right.
And I don't understand how they calculate if it's a parabola, if it's one that's going to return or not. I just don't I don't get that. But maybe we can deal with that later.
Well, no, it's very easy to deal with just in talking. We can make some charts that illustrate it too for later.
Okay.
But all the orbits, when you figure out orbits around a central gravitational source, And for the sake of comets, unless it comes near a planet, it just is responding to the sun's gravity. And so its orbit is going to be a conic section. And there's two types of conic sections. There's open and closed. So if it's open, it came from somewhere and it's going back, and we ain't never going to see it again. So that's a hyperbola or a parabola. If it's a closed orbit, it's either a circle or an ellipse. An ellipse is the general case. And it will be back again.
Well, if it's an open, it's like Oumuamua, a visitor from another solar system, and it's just passing through, isn't it?
That's true. That's the test of whether it's interstellar or not, if it has an open orbit.
Okay.
One of the things I've learned, gentlemen, over the 4 years of us doing this is that there's rocks going around all the time. These asteroids that nearly miss the Earth could become comets if they had water on them, wouldn't they?
They might have been comets once.
But that's the key. That's the key to tail.
Yes. Well, not water, but volatile materials such as water, CO2, anything that's frozen on the surface that when it gets hot, it turns into a gas, like nitrogen or oxygen, all sorts of things. There's mountains made out of nitrogen, for example, frozen nitrogen on Pluto. Now, if Pluto were to come in close to the sun, all those mountains would turn into gas, and Pluto would have a hell of a tail.
And for some reason, you can see gas as a cloud in the dark of sky. I don't understand.
You remember the old medieval periodic table consisting of 4 elements?
Oh, yeah. Air, dirt,
earth, fire, and water. Yeah. They weren't too far off, not in them being elements, but those are actually the 4 states of matter. Everything exists is in either a solid, liquid, gas, or plasma. And that's what those 4 things are: solid, liquid, gas, and plasma.
Okay. I looked up on YouTube, or not YouTube, Google the other day, how many types of plasmas. We're going to have to make that an interesting topic. There's a million different kinds of plasmas.
No, there's only one.
Well, I mean, fusion is different from oxidation.
Yeah, one's nuclear chemistry and the other's chemical chemistry, you might say.
But in fission, fusion, I mean, just anything boiling, gases into flame-like structures, isn't that all plasma? The 5th state
No,
of
the flame itself is the plasma.
I know that, but
is its atoms torn apart.
Ah,
it's ionized atoms is plasma.
I think it'd be a fascinating topic in the future, Mr. President.
Okay.
Sometime.
Well, the math is pretty hairy. The field is magnetohydrodynamics. So
that's 4 times.
Okay.
Okay, this is a picture of Comet Olbers taken by an amateur in, I think this was in Arizona.
Tucson, there it is.
Mike Olison, Tucson, Arizona, right. So he took this with a 50 millimeter f3.5 lens. And
looks like a 5-inch scope.
No,
that's 2-inch. That's about 2-inch.
Yeah,
Tim.
What about above it? It says aperture diameter 5 degrees. Never mind. I'm misreading that.
Okay. He doesn't put the magnitude on here, but he did blow it up and circle it. So, and the length of time, it doesn't say how long this was. So, okay. Anyway, it's visible in a small amateur scope by imaging, and probably visibly too, if you have a 10 or 12 or 14-inch scope. Now, the other thing that's going on this time, right now, it's a really great time because it's new moon tomorrow morning. And so you get a chance to look at the dust in our solar system twice a year. You get to look at it in the evening during new moon in the spring. Right now, the conditions are right for that. And you get to look at it in the morning sky in the fall. And this is a picture of the zodiacal light sticking up here that's actually brighter than the Milky Way is. This is a very dark site, and it looks like it's way far north.
Is that a sun or a star in the middle of it, right above the horizon?
That's probably a star like Jupiter or something.
Oh,
If it were the sun, the sky would be blue.
and it's zodiacal, not zodiac light. Could be either.
You can pronounce it zodiacal, whatever your memory is triggered by.
Gentlemen, we were delayed going on, almost delayed by an incredible photograph that Bruce threw up on the screen. Was that, Bruce, was that the comet earlier?
That was
was
the
a
comet
different comet.
Neowise.
Neowise, yeah.
Oh, I see another one. Okay, now here
Yeah.
we go. Asterisms are us.
Yeah, asterisms are us. So we have the summer triangle and the winter triangle, and now here we have the spring diamond.
Right. Hey, Jerry, I'm
Yeah.
used to eliminating Corcoroli, which is one of my favorite doubles, and calling Arcturus denebulum spica the spring triangle. That's what I was used to, spring triangle. And I point that out star parties with the green laser. But
Okay.
Oh, okay.
this is neat to have another element, another member.
Was this the Arch of Spring?
No, that's different.
Oh, that's coming up. Okay.
These are different these really big asterisms like this.
Yeah.
It may be just as my dad used to say, a little known fact hardly worth knowing. But if you're out there in the sky, if you're out in the evening sky trying to get oriented and find something to show someone, your girlfriend or your wife or something, these big asterisms are very helpful. They're easy to spot, the brightest stars, the simplest patterns, and they orient you to where you are and where you're looking. And
Right.
from there, you can do star hopping in your mind and then use the laser and show it to people.
The
This
summer
is-
triangle is also quite visible now.
It's starting to come up, yeah.
Well, I mean, I go out and look at 2 a.m. or something like that, and it's up there.
Yeah, you're doing time travel into the later in the year, though,
Yeah.
by getting up in the morning. We're talking about normal people, Bruce, that stay up only in the evening.
Yeah. So another thing I'll point out, Jerry, is that, the orientation of this beautiful diamond, when I see it here in the backyard, Arcturus and Spica are kind of parallel to the horizon. So if you imagine this little diamond being rotated counterclockwise, I don't know, 90 degrees or so, that's how I see it. Okay.
Oh.
Thank
there
you.
go. Ah,
Yeah.
that's how,
That's exactly how I see it in the backyard, Jerry. Thank you.
Okay.
So that's how we look at it.
Yep.
That looks more like a diamond though than the side version.
Mhm.
Yes.
Yeah.
Now, right up here, there's a little spray of stars.
Yeah.
And that is a very loose open cluster. And this is an image of that open cluster taken by, I don't have my
Some wide
points
field,
here.
some wide field instrument.
Yes, this was taken by a handheld camera by an astronaut on the International Space Station.
Wow.
Oh, wow.
I forget his name, but this is your Mello 111.
Mm-hmm.
Oh, there you go. Okay.
Or Tim Berenice's hair.
Yeah.
That's a
Oh,
star cluster.
okay.
She cut her hair off.
See right up here, this is Coma Berenices,
Mhm.
and all this spattering of stars going up here, that arc, that's her hair. And the ancient myth. Go ahead, Tom.
I was just going to say, she was technically married to her brother, who went off to war, and she promised if he were returned safely, she would cut her hair off, and she did that. And then she took her hair and put it in the place where things about Venus are held, and it suddenly disappeared. Okay. So as a gift to her, her hair went up into the sky as a bunch of stars.
Hmm.
Crazy
So they
myth.
Nice story, Tom.
Yeah.
That's
Yeah, that's a Berenice's hair.
I
But
think
they
we'll have to
didn't leave it
visit
in
that
fun.
one, Tom.
Very,
But
very,
there's
very
only
pretty
about-
again in binoculars. Also, I
Mhm.
point out if you go to that previous picture, if you can do that, Jerry, the previous one, you notice where Denebula there is the tail of the lion. And so a
Yes,
long time
there's
ago, and Chuck
Leo.
pointed this out at star parties, that Coma Berenices used to be a puff of a tail of the lion. So you used to kind of attach it to the tail of the lion, like
Oh,
that.
interesting. Interesting. On that other leg between Corcaroli and Arcturus, I think is M3.
It's
Mhm.
what?
M3 is right about in there, Jerry. And
Right, you're right where your cursor is, Jerry's M3, that beautiful
Yeah.
globular cluster.
Okay.
Hmm.
A lot
the
of
hairs-
opportunity with it looks like the sky is going to be clear the next couple nights
Yeah.
and the moon is new tomorrow morning. So
Mhm.
you have the dark side all
Yeah,
welcoming you out there.
it
Yeah.
is the time of year for May gray and June gloom.
Yeah.
Yeah,
Lion
we're
O sky
lucky.
and Fogus too.
Yeah.
August is coming our way.
And Ron, do you know where the phrase new moon comes from?
Sounds to me like it's just brand spanking new on the sky. It's
No, it's Old English. It means no moon.
you're kidding.
From the Old English, it's no moon, right? Because the
No.
moon's gone away. It can't be new.
So the new how did they spell that, Tom? It's not
I don't know in the
Oh,
original.
okay.
If you
Okay.
look at Old English,
E-E-L-U-D-E.
you would not recognize any of the words of spelling.
Right.
Yeah.
It's almost a completely different language.
Yeah.
It is.
Imagine they got used to it and didn't get excited like they do at an eclipse every month. Disappears, so it'll be back, guys.
Nice.
This is a chart of the structures and sky things that are within 100 parsecs of our sun, which is at the center. A parsec is about 3 light years. So this would be about up to about 300 light years.
Mm-hmm.
And
Where the hell did that word come from? Parsec. Who cares?
it's an acronym for
Parallax of 1 second of arc.
right, good.
Oh,
Thanks, Jerry.
Nice. I never knew that. That's good.
Yeah.
okay, that's our neighbors.
It's our neighbors, the Ursa Major moving group. These are stars.
Mhm.
Okay,
And this moving group is believed to be a group of stars that were born with the sun in the same nebula, same nursery at the same time. I don't remember the other name for Melot 111, but it's supposed to be on here somewhere.
Mhm.
what we're
Yeah.
looking at is stars in the spur and not in the main arm.
No, this is
We're all in the
yeah,
spur.
this is in the
right?
plane of the galaxy,
Mhm.
Oh,
but it is close to us in the plane, so that you're looking down on the flat surface of the galaxy.
okay. But we are located between arms, aren't we? In a little spur.
Well, that's a whole lot further in than this is.
Okay.
Is it Colander 256 maybe?
I think that's it.
Yeah,
Yes.
it's definitely a colander, Tim.
Now
Colander
these
256. And
these shadings out here, these are the arms of the galaxy,
Oh,
and we're
It looks
located
like a
between
Batman
arms.
shield.
What's that?
It looks like a Batman shield.
yeah, that's what I was about to say. That's what I was like,
Okay, too many
Yeah.
comic books. Okay.
Yeah, that's right, Tim. Colander 256. You got it.
Yep.
no plans to go visit.
I think it's
I don't see it.
It's just under coma there, next to the sun. I think that's
Coma?
it there.
That's
Yeah.
yeah. Could be. Well, yeah, because Coma Bernices is up there.
Yeah, it's got to be it.
Yeah.
Where's Alpha Centauri? That would be the closest to us.
Alpha Centauri?
Yeah.
I don't think that's this close. Well, what is it, 18 light years away or something?
No, only 4.
No, that's Proxima Centauri.
Well, Proxima is one of the.
Oh, Alpha Centauri. I heard Sirius. I thought you were talking about
Okay.
Sirius. Sorry.
That's okay. It's a 3-star system is Alpha, or is it?
Yeah, this is not showing individual stars,
Oh, I see. Okay.
showing associations and objects.
Oh,
The Spica is here, but Spica Nebula
Oh, wow.
is that object. Okay. So
Back to the night sky we go.
yeah, we're getting it. This is the sky. This is south, southeast, south. So this is on the rising part of the sky.
Mhm.
You can see the constellation Corvus and Virgo. And
Mhm.
right on the border here is M104,
Yeah, the sombrero.
which is the Sombrero Galaxy. It's a very dramatic galaxy. It was in the closing credits of the Outer Limits sci-fi show in the 60s, the series. Quite dramatic. They had an excellent photo of it there.
Remember
This
the
is-
opening, ladies and gentlemen, we are in control of your horizontal.
Yeah. Do not
That's
attempt to
Control
adjust your
transmission.
set.
right.
So it's got a lot of structure for a spherical galaxy. It's a regular galaxy. It's got this heavy dust ring around it, and you can see on the inside of it, of the dust ring, you can see all these layered dust things, heavily illuminated by this bright core. It's an excellent object. You can see it not to this detail in amateur scopes, and
Yeah.
it's a
Yeah.
good object to take pictures of. It's slightly in the south here.
Oh, yeah.
I can't remember the star hop to this, but I do remember that
There's
when
a little, Tim, there's a little arrow that points to it.
that's
Remember
it
that?
exactly.
Yeah, and we,
When you're near, you'll see like three little arrows, three little
I was
stars.
just going to mention in Tucson, we imaged this in the 61 inch. It's,
Oh,
it's
wow.
yeah, it's a pretty spectacular object.
I'll bet even looking at it visually in the 61 inch.
Yeah, yeah. I had to put on my sunglasses, Jerry.
Well, you should have been looking at the Sunflower Galaxy then. So
Nice.
up here, this is a galaxy cluster up here in Coma Berenices. This is the season when we're looking out of the north side of our galaxy. So we're looking straight up. The Milky Way is all around the horizon at this time.
Mhm.
And this is the tail end of Leo with M95, M96, and the NGC that is the third one of the three, the Leo triplet. Or is that,
Yeah,
no,
I
that's
can't
M65, M66, and the NGC, it's over here.
Hmm.
So that's the Leo triplet over here.
Mhm.
Yeah, it's a 36 something. I can't remember.
28,
Yeah,
36,
it's an
28.
NGC now, but it's just as bright as the others. I don't know why Messier didn't see it. And then over here is M3, as you pointed out in an earlier
Mhm.
star chart. So this is the Virgo cluster up here,
Mhm.
probably the nearest and most populated to us. Most of these galaxies are spherical galaxies, irregular galaxies.
3628. That's what
Yeah.
it is.
Yep.
NGC 3628. Yeah, it doesn't even have a dot on here.
Yeah, we call it the hamburger up north.
Oh,
Yeah.
is that what it
Chuck calls it the hot dog. We call it the hamburger.
So would it be fair to say, gentlemen, that within the Milky Way, we have star clusters, but way out there beyond, we have galaxy clusters?
Mhm.
Yes, we are part of the Virgo supercluster.
Yep.
That is,
Wow.
there are clusters of galaxies, and then there are clusters of clusters.
Are we looking at two clusters on, there's one up in the right and then the majority in the middle?
No, these are all part of the Virgo cluster.
Oh, that's all.
And we are not that far away on galactic scale. We are part of the Virgo supercluster.
But old man
Okay.
Messier didn't name the whole thing as an M. He named each one of the participants.
Yeah,
each one of the
he was
galaxies.
looking for comets. He was a very focused guy.
No pun
He
intended.
paid money if he
No
found
pun
a comet.
intended.
Yeah, they got he was a transitional astronomer because they were transitioning from because they believed in astrology, and they believed that a comet was an omen of war or death of a king or something. So the kings always wanted to know if there was a new comet in the sky. So people were trying to find the new comet, and they'd get a cash award. Sometimes it was enough to retire on as an award for doing that. But then Messier was doing this, making his list of not a comet, And he found out that other people were getting their stipends or their rewards by making catalogs. And so all of a sudden he formalized his catalog.
But did he
Oh,
put
that's
it?
interesting. I never knew that.
Did he
Yeah.
put it? Did he put an M on a comet that just disappeared and went back out of sight again and had to?
I think there's one or two controversial Messier objects that he repeated, he saw something and misrecorded its position, and because right now there's nothing there, so it might have been a comet. He might have just got his coordinates wrong.
Yeah, I can't remember. There's something. Let me see if I can find something on that. It's like
Yeah.
M111.
It's like
M41?
there's just at that position there's just one star.
Yeah, M41.
M41.
Yeah, I think that's it.
So,
Okay.
It's up in Ursa Major.
So your story about Messier is that he started looking for comets and was going to give them a number until they disappeared, and now his numbers are all permanent. Pretty much, they're always there.
No, close, but no cigar. What he was doing was looking for comets, and the way you look for a comet is you see something up there that's a faint fuzzy, and you make a sketch of where it is with respect to the stars up there, and then you come back a few nights later and you see if it moved. If it moved, then it was a comet. So then you discovered it. So what he did was, rather than he'd find so many of these things that were not comets that he made a recording of them. So when he found them again, he didn't have to come back and look at it a second time. He just knew that it wasn't a comet and he moved on.
Oh, interesting. The comets have names, not numbers.
Yeah.
Well, actually, 13P is a number.
Yeah, 13 is the 13th one that's discovered in this year, and P is a periodic comet. It means it's coming back again.
Okay. As opposed to
So,
okay.
This is the arch of spring.
Here we go.
These bright stars form an arc. Summer, winter, those things are all angular. Here we have a more advanced structure, an arc.
Is that above some buildings in our town?
This is random. I don't know where this is.
Oh,
It's not this time period either, because Mercury is right here, and this looks to me like kind of an evening.
yeah. Definitely evening.
So
Arch of spring.
I don't know if it. Let's see.
Jupiter.
Yeah. Oh yeah, this was taken in 2014.
Ah,
But it was May of 2014.
Yeah.
And
So
is it-
anyway, Procyon, what's that? The second brightest star in the sky, or one of the brightest ones? Kappa Geminorum, Gemini, Pollux, Castor, and Capella over here. So these form the arc of spring.
which is an asterism?
Yes, it's an asterism.
Okay.
People without telescopes on ships and stuff would learn these big, not constellations, but they'd learn these big asterisms.
Sure.
So they could say, this is west, or this time of year, that's south, so they could orient.
Jerry, my dad being a sea captain, he took me out into the patio one night, and I think this arc of stars is the very one that he was showing me, along with Sirius, and saying that I navigate by these.
Yeah.
And so that's interesting.
Now, down through history, and even prehistory, people, even Polynesians and Europeans, when they were exploring the world, they guided by stars. They did a nighttime navigation. And then when Galileo discovered that Jupiter had 4 moons around it, the claim was that proves that not only is there life on Jupiter, but that there are sailors on Jupiter, because they need 4 moons to guide their ship. God gave them 4 moons to guide, because it's such a big planet.
Wow.
Which came first in the northern sky, the Bear or the Dipper?
I don't know how to answer that.
Well,
the stars are always been there.
But the
different.
Dipper,
These things are named by different mythologies and different customs and different societies. So
well,
I don't know.
but
You'd have to
the,
ask Chuck next week.
the Dipper is the asterism, the Bear is the constellation, and it involves, I think, more stars than that are in the Dipper, right?
Yeah.
Okay,
Yeah.
that I know. All right, thank you, Taurus. There's my sign.
So tomorrow morning, May 7th, the moon is new. And then the day after that, May 8th, the moon here is drawn extra large. It's not going to cover the Pleiades here. So, but this shows the moon in the first few days of, or the later this week, right after sunset, as it moves up into the evening sky. The stars here are setting. This is the west, looking west northwest.
Huh. Ah, here we go.
Okay.
Top
Now
pick.
the evolution of stars.
Never gets old. I love
You've
it.
asked about this a number of times,
Mhm.
but this was a nice chart that I found on the internet. It's all in the mass of the stars.
The big guys go away early.
What's that?
The big guys go away early, unlike on campus where they
The big guys live a hot, short life and explode and die violently.
but us little guys.
So the little guys, it depends. They start from a stellar nursery, and this is just a cloud of gas and dust and previously exploded stars. So there's a lot of metals in it, a lot of higher elements than hydrogen, but still they're mostly hydrogen, even at this late stage in the game. And so the size of the star, the density of the cluster or the density of the nebula determines the size of the star, because all the little grains in the nebula, they all attract each other gravitationally, and they pull each other together. And as they clump together, they after a while, the new stuff adding on the outside just becomes a weight crushing down on the ones that are there already. And that weight, that crushing down effect, makes these particles, which are at a certain temperature, bounce and rub against each other, and it heats them up. Just the same as you do in a diesel engine to get the diesel fuel to explode. You compress it really quickly, and that heats it up, and then it explodes, it lights. So when you compress this stuff, it gets hot. And when the temperature reaches in excess of 10 million degrees, then it's hot enough for molecules, or rather ions, when they hit hydrogen nuclei or protons, they can stick together and they can form helium. And so fusion starts. And once fusion starts, then you have energy trying to get out, all the photons that are released from the energy of fusion. And that stops the infall of material from the nebula. Now they have a solar wind, and the wind is pushing these particles away. So that stops the collection, even though there's still a lot more gas and dust to go. In some cases, the gas and dust in the nebula is denser, and so a lot more can get in to do the crushing before fusion turns on and it blows all the rest of the dust away. So how fast it comes together determines how much you're going to get in there before fusion turns on and blows all the remaining dust away. And so that's the chief difference between a big star and a little star.
But however, you can have big stars that are red, like Betelgeuse, and thousands or millions, gazillions of little ones, little red dwarfs. Does that mean they're all in the infrared? And if you were on a planet orbiting one, you wouldn't see ultraviolet or blue, you'd see mostly reds?
Well, the star color is determines the surface temperature, not the core temperature, but the surface temperature. And a big star tends to be farther away from the core. The light has to convect or conduct out to get it hot. The heat has to conduct out. So they tend to be cooler. The bigger they are, the cooler they are. But there, of course,
How
there's
big
some
is
blue stars that are bright.
how big
Really?
is Herschel's garnet? Because that's quite red.
I don't recall specific ones, but giant stars are considered over 3 times the mass of the sun. And what happens is that these things, as they're a star, no matter what size there are, they live in equilibrium, dynamic equilibrium. The gravity is continually pulling them together, and the radiation is continually trying to blow them apart. And when the two balance, then the star has a size, and it lives that way for a while. Now, the rate at which it does its fusion and burns hydrogen is determined by how hot it is at the core. And with a sun-like star, it stays in the hydrogen burning stage, for example, with our sun, it's going to stay like that for about 10 billion years. So we're about halfway through that, about 5 billion years. And so we've got another 5 billion years before it has used up all its hydrogen. And then there's nothing pushing out on the star again. So now the star will collapse and the temperature at the core will go up and it'll start burning helium. But there's not much helium in there and it's a hotter temperature. So it's not going to last as long. It's going to be a few million years. And then it's going to, as it progressively goes through different stages, it's going to progressively get hotter in the core and burn other materials. Now, every time a stable period ends with the star balanced, so the outgoing pressure and the incoming gravitational weight balance, at the end of that, the star then does a quick collapse again. And eventually, when it collapses, and then the fusion at the next level starts up, then it pushes back a little bit. And these can get so violent that it starts blowing off the outer shells of the star. And that's where you get planetary nebulas.
Oh, but there are such things as super glowing blue stars or white stars that are so hot they're going to go really fast, right? As big as they are and as
Not necessarily. What's going to happen after it forms this planetary nebula, it throws off its outer core, then it's basically done fusion. It doesn't have enough mass to do any more fusion, and it becomes a white dwarf. So a white dwarf is just the leftover ashes. There's no fusion going on, but it's very hot and it's white.
It's just a step above black hole or a neutron star.
Well, it depends how much matter there was in the thing, because once it throws off its outer shells, then what's there will settle down. Now it's not producing fusion anymore, so it's not pushing out. So if there's enough mass, it'll crush in enough and become a black hole. But if there's just short of that mass, it'll crush in and become a white dwarf.
Well, Jerry, can you delineate which stars are associated with the following three novas? There's the super, there's the hyper, and there's the killa.
Those are all big stars.
Yeah.
Are all big stars, or they're just variations of the theme?
Well, not really. Some are just like a simple star that got too big and went through its hydrogen, all of its different burning stages. And when it collapsed, it was so massive that it just exploded. The other thing that happens is when you have binary stars, and that's where some of these novas come from, supernovas, because there'll be, for example, after this, there could be a large star orbited by a white dwarf, for example, that started out as a binary star. And the white dwarf is close enough. It's gone through all these stages, but the supergiant is still a supergiant. And it's going through these stages, but it's peeling off hydrogen from the giant star, and it's landing on the surface of the white dwarf. And so it's now building up its weight. And then all of a sudden it gets hot enough to do fusion again, and it will fuse. And that's where you get a type of nova, recurring nova, for example.
Oh, okay. This is fascinating. Jerry, Chuck, on the planetary nebula for the sun-like stars, I've just repeated what he said, that the star just eventually just burps off layers. But you described it really well, that it kind of collapses, and in that there's a violent expulsion of the layer. And
Yeah,
that I didn't know.
it collapses and it hits all the other material down there, and then it bounces back
Yeah.
because it like over compresses, and then it'll burst back, and that's where you get these little explosions that throw off the outer layers.
That I
When you
didn't.
get a really big star, what's that?
I really learned a lot here for the outreaches, and this is really valuable. Thank you
Okay.
very much.
Well, can I bring up something that has always bothered me and I don't really understand? Solar wind is
Yeah.
constantly going.
Yeah,
I imagine that would add up after a while,
it
considering it's
does.
happening eons and eons, and they're all doing it. All the stars are
Yeah.
sending out protons and stuff, and it's going away. Why don't they just fizzle out?
Because it's a slow enough process that it doesn't all get out before the star can blow up. You know that our star is projected to when it's run out of its hydrogen, it's expected to expand into a giant star, a red giant, and it's going to expand its orbit out to about the orbit of Earth. Mercury and Venus will be absorbed into the sun. And if the sun stays, which it won't, but if it stays at the mass it's at, then the Earth would be absorbed. Mm-hmm. But just what you said, in the next 5 billion years, the sun will have emitted enough solar wind that the mass of the sun is reduced by about 10%, and it will not have enough mass to expand all the way out here to the Earth. Mm-hmm. So it doesn't mean the Earth's going to be saved, because the sun will be so hot at that time and so close, it will have boiled off all the seas on the Earth and will just be a dry cinder. So we have to move to higher ground. We have to colonize Mars.
Look, there's a neat science fiction story.
Well, there's a dozen science fiction stories that take advantage of this stuff. The best one is one by Larry Niven back in the 50s called Neutron Star. And this guy develops this spaceship, and it's made of some impermeable material, and he's going out toward this neutron star that's about to become a neutron star. And as he goes out there, he notices that parts of his ship are missing, like his antennas and his tail fins and stuff. And he goes, "What's going on?" So he does this. He's observing and analyzing it and stuff, and all of a sudden he realizes that the star he's approaching to explore is an antimatter star, and its solar wind is antimatter, and it's basically burning up his ship as he gets closer. So he immediately turns around and goes back.
That's a good one.
I first read about black holes in an article inside Rolling Stone magazine back in the 1970s something, and it detailed a similar story, only they saw on the screen on their gauges, in the spaceship, oh my God, something's locked onto us. We better turn around and get out of this. It's a black hole. What the hell was that? Amazing.
I think Bruce was asking about Herschel's Garnet star. I think that's Mu Cephei, and the radius of that star extends out past between Jupiter and Saturn. It's just huge.
Wow. Well, has science ever come up with a percentage or a nano percentage of whatever the sun's solar wind is that goes out in all directions? How much of it do we get? It's got to be minuscule, almost nothing compared to how much is going.
Oh yeah, it throws out stuff in all 4 pi steradians. And we just are you're right, we're just a minor slice of the pie.
And yet everything, and looking around us today, it's
throw off.
Makes everything grow.
Got us.
Wow, fascinating stuff, gentlemen.
A coronal mass ejection hits us directly square on. It would basically send us back to the 1850s electronically.
Oh wow, I've heard that.
What's the average rate of a nova? Once a year, once 100 years?
No, there's no a recurring nova. There's no standard for that.
I'm just talking about how often does a big one blow? Don't they
Oh,
see them in distant galaxies? Suddenly it lights up but they're very
there's
rare.
one that's about to go again, and I think it's like every 100 years it blows up.
God, you'd think with the
We
many
talked
stars,
about it about 2 or 3 months ago.
I know. I just don't understand how there can be so many trillions of stars and so few supernovas.
Oh,
Well, they're a
no,
long ways away and we can't see them easily.
yeah, there's novas every night. I mean, there's hundreds a night.
And we don't see them?
Yeah, you see them with telescopes, they're very far away.
Okay.
There are more stars in the universe than there are grains of sand on all of Earth.
I
By
understand.
orders
That's
of
why I would
magnitude.
think it'd be like twinkling
Mhm.
lights, in a
Now
city street.
let me go back and clarify one thing. We have in this chart, we have a white dwarf, which is a cinder left over. And I said this was a black hole. It's a black dwarf.
Mhm.
I was thinking down here.
Black
And that's
dwarf?
just a white dwarf that cooled off. Because
Oh, okay.
there's no source of heat in the white dwarf. It's just coasting from here on. It will eventually become a black dwarf. It'll emit no light in any band. It will be completely cold. And that's what in the 1800s they called the heat death of the universe. It's eventually,
I didn't
yeah,
know
go
that
ahead.
was for that.
You what?
I didn't know that the black dwarf is what they called that. I knew
Yeah.
they just kind of got cold, but
It's the end point of virtually everything. But the giant supernova stars, they become a black hole or a neutron star.
So black dwarfs don't have a singularity or an event horizon.
Everything has a singularity. It's just that the singularity is way inside almost everything. In these black holes, the singularity is outside the mass.
The white dwarf cooled down to become a black dwarf. My God.
Yeah, it's like you pull a burning cinder out of the fireplace at night or something. You can see it's glowing red, and you put it on the bricks, and eventually it will turn black because it loses its heat.
so it'll be Snow White and the Six Dwarfs.
It'll be what?
Snow White and the Six Dwarfs.
Yeah.
But it's something like that isn't fighting, between its fusion and its gravity, though.
No, it's the gravity one.
Gravity one. Okay.
Gravity one.
Fascinating stuff. Did we get through everything? Is there another topic?
No, we got through everything.
Well,
Fantastic.
can I ask a question?
Go ahead.
Just to clarify, this is about it, since we're down to the wire. I looked at the calendar, and the first Saturday of the month is the 1st of June. Are we going to go to the second Saturday, which is still a week before our 14th of June Friday night meeting? If you got your calendars handy, gang, we start the month of June with a Saturday. Is that when we're going to have our star party, or is it going to be the second Saturday, as usual, but it'll be the 8th, I think?
That I don't know.
We'll discuss that at
Friday
this Saturday's
meeting.
our business meeting where we set the calendar. That'll be next Saturday.
Yeah.
Okay. Otherwise, what do we got? Westmont coming up Friday night, or is that done?
The third Friday will be Westmont.
Yeah, which is the 17th of May.
Okay, that's the 17th. And
Mhm.
our beloved outreach coordinator is celebrating his anniversary, and then it's going to celebrate going on to the knife on Thursday. I hope he's going to be up and around for, I guess, next Tuesday would be out at Camino Real. There's a Tuesday telescope night, isn't there? I went to it a couple times.
Yeah, Telescope Tuesday a week from tomorrow. Chuck
Mhm.
will not be there. Tim and I are going to run it.
Oh, you're okay.
Right. We're not going to have the workshop that night.
Right, where the workshop,
Yeah.
telescope workshop won't occur.
Yeah.
Well, Tim,
the
is there? Go
Oops.
ahead.
Yeah,
Tomorrow night?
Ron, the 17th is going to be our Westmont. At the 18th, I believe, is the astronomy day.
That's
Oh,
right. That's right, Tim.
Yeah.
Yeah.
And we have telescope. No, what do we have? Workshop on Tuesday. That's tomorrow night, right? Still online?
Yes. Yes.
Okay, we are involved with so many things. My God, let's do it again. Number 168, I think it'll be next week on Monday morning. Good to be
Tom,
back.
I'm gonna reach out to you, Tom. I may do the mirror grinding on astronomy day. I'll reach out to you.
Oh, okay. Okay.
We're happening,
Yeah,
gentlemen. There's no question about it. And we get some good speakers too. I wonder what that vice president, how he does it. Well,
Yeah.
Gary, thank
Phenomenal.
you.